and then we can begin. So today we will look at reprocessing and pipelines again. So I know we've already covered this, but I want us to redo this. So what I'm going to use is the data that I've shared for the project that you want to do for today. Okay, so I've deleted the data on my side. So let me download another data set. So as we mentioned before, we will be getting data sets from online sources, and we will be using those data sets to learn a few things. So what we are going to do today is the pre-processing and pipeline parts. And for pre-processing and pipeline parts, we are going to see how we can handle these requirements that we need to fulfill when we are creating machine learning models. So the first requirement that you need to know is ML models. So all datasets should be numeric. So for most models, all columns are required to be numeric. Then we should have no missing values in the data. And with real world data, this is rarely the case. So we have lots of missing data and we need to pre-process this data. So when we are dealing with ML data, we have categorical data. And when we deal with categorical data, for example, if you are dealing with some store sales data, you can have a column called size. And we have each row with an observation. So for example, you can have medium, large, small, medium. So these are four different observations. So if we encode these columns to be numeric, we get this. So we get column L with a 1, column medium with a 1, 1, and column small with a 1. So each row filled with a 1 corresponding to where the item appears. So for example, L appears in row 2. So we have a 1 in row 2 where we have L. But for M and S in row 2, we have zeros because they are not appearing in row 2. So this is how encoding works, okay? So before we proceed on with this theory part, let's find a data set that we can use for today's session. So I'm trying to get data that has been uploaded most recently. So maybe let's pick a classification task. Then hotness, we can click on updated. And then here we have datasets that have been updated just recently. So maybe we can pick this one here, maternal health risk. But I guess we've already covered a problem where we are dealing with health data. So let's pick data in another field. Okay, I'm trying to find a data set that we can use for today's class. Maybe we can pick this one, financial application behavior dataset. So let's see some of the columns that we have in this data. So we have user, first open, day of week, age, screen list, number of screen mini games, and role. I won't pick this one. Let's find another data set. Okay, so just give me a minute as I am doing this. Let me add some filters. So it should be a CSV file, maximum maybe 5 MB. Then usability rating 9 or higher, highly voted for learning. and maybe application. So let's check for learning. So those are the filters that we are checking. So this was updated a month ago. So let's pick it. So employee dataset. Yeah, so I guess we will work with this and try to see the kind of problem statement we will create. So I'll share this link with you here and I'll download this dataset. Save it in the class documents folder. Then what I'll do is I'll upload it to GitHub again so that I can share a link with you to access the data online. This is the employee.csv file that we have. And then I'm going to view row. After viewing row, I'm going to share that link with you. So this is the link we will use to get our data. So let's go back to our presentation, but before that, let's create a new notebook. So let me open the class folder. And this will be the employee analysis IPYNB file. So here what I do is I import some basic libraries. So let me zoom in, then you'll be able to see my code a little bit better. So we're going to start with importing libraries. So we will have import pandas as PD, numpy as NP, matplotlib, and seaborn. Then we are also going to import warnings so that we can ignore all warnings. Okay. So this is the code that we usually use all the time when we are dealing with our data. Then I'm going to read in the data. So we're going to have our data being equal to pd.read underscore csv. Then I'm going to paste in my GitHub link. Then we can type in data.head to see the top 5 rows of our data. So for today's class, we are basically reviewing some of the things we've done before and reminding ourselves how they are done. And maybe what I'll do today is I'll pick the best approaches for you to follow when doing these. So if we go back to these notes, so the first thing we need to sort out is numeric data. So the first thing we need to do is we need to encode our data set. So I'll add a cell here for that. So encode data. Then what's the second thing we need to do? So after encoding the data, another thing we need to do is we need to check for duplicates and missing values. So that's the other thing we have to do. And Lastly, the last thing we need to do is normalize the data. So these are the pre-processing steps that you always follow when preparing your ML model for when preparing your data for ML. So let's go through the theory part here because already we've imported our data and it's here. So we can go through the theory part here and see some of the things we need to know. So already we've seen how encoding works, okay? So the next thing we need to look at is how do we handle missing values? So missing values are those values that are not there for a specific feature. And how do missing values occur, or what are the common causes of you having missing values? So there might be cases where the user failed to input that value. Maybe the data might be corrupt, so meaning that some parts of the data are missing or have been damaged. And another reason will be that this field might be optional. So yeah, you are expected to have multiple missing values to this feature that you have. So how do we handle these missing values? So we can drop these missing values or we can impute them. So we can impute them using different methods. So for example, you can impute them using an ML model. You can impute them using the mean, mode, or median. So something like that. And yeah, that's for missing value. Then we have centering and scaling of data. So centering and scaling of data is the reduction of the distance that you have between the maximum and the minimum value, okay? So here you can see, for example, many models use some form of distance to inform them. So when we were learning the K-means model, you saw that it uses distance to make decisions because we are dealing with items that are close to each other. So the same applies to KNN, that is the K neighbors classifier model. Okay, so features on a larger scale can disproportionately influence the model. So if you have these big values, they can influence your model and they can either lower the model's score or they can, yeah, so the main thing you need to know here is that they influence the performance of your model. So an instance will be KNN uses distance explicitly when making prediction. So we want features to be on a similar scale. So if on a similar scales means that we want features to be either from 0 to 1, so us having a minimum value of 0 and a maximum value of 1, so which means that they are in a similar scale and not as having a minimum value of -10 and a maximum value of 1 million. So you can see that's quite a huge range, right? So how do we sort this? So we normalize or standardize the data, which is normally called scaling and centering. So how to scale? So we have different ways of scaling. So we have min-max scaling and the other. So we will discuss that. And the last thing we do is we create pipelines. So on the practical part, I'll show you how we create pipelines. So that should be our last part here. So pipelines. So let's begin. So we have our data set here and you can see the top 5 rows. So we have the education, joining year, city, payment tyre, age, gender, ever benched, experience, current domain, leave or not. So what we are going to do, so actually I won't fit an ML model for this data because we are currently just dealing with imputation, like the checking of missing values, the change of categorical variables to be numeric, and the creation of pipelines to like do that preprocessing all for you. So the first thing we are going to do is we are going to check the data info. So we are going to have data.info, and here you can see this is the data that we have. So we have education, which has 4653 observations, and the whole data has 4653 observations. So if we check, we can see that all the columns that we have here, they do not have any missing values. Okay, so that's the first thing you need to note. And we have 1, 2, 3, 4. So we have 4 categorical columns, and we have 1, 2, 3, 4, 5. We have 5 numeric columns. So what I'm going to do here is I'm going to create a list. So I'm going to create a list of numeric and categorical columns. Okay, so we can have num columns being equal to data dot select underscore d types, then include np dot number, then you get the columns, then you convert them to a list. Same for categorical columns, data dot select d types exclude np dot numbers, then you convert them to a list. So let me share that code with you, and then we can proceed. So the reason as to why I'm selecting these columns is because when we will be doing our pre-processing, so we cannot scale categorical columns because we already know that these columns are categorical, but we can scale numeric columns. So maybe I can go ahead and check my num columns, and these are my numeric columns. Yes, so that's what I have. So 2 minutes, you copy these, and then we can proceed. So for today, an assignment for you will be, so maybe I can include it up here. So this will be an assignment for you. So something that you are supposed to do maybe tomorrow. So create a problem statement about the data set. Then create problem statement about the data set. Let me delete this. Do some EDA. And then lastly, create a model to solve the problem. So is it a classification or regression problem? So you will decide on that. So depending on your problem statement. Okay, so 2 minutes, you copy these, and then we can proceed. Since we have no missing values in this data, so what we will do is I'm going to introduce some missing values in the data, and we will assume that those rows were corrupt. But before that, we will have to do the data encoding. Or since we have to do the data pre-processing in the pipeline part, all using a pipeline. So what I'll do is I'll have to introduce missing values here. first of all, we are going to create a data copy. So this will contain our data there. Then for columns in columns, so we are going to create some missing values here. So this is what we have. So we have some columns that have some missing values. So let me explain this code that is here. But before that, let me share it with you. And then we can discuss what I'm doing here. So we've created the data copy here. So why are we creating our data copy? So this is to ensure that any changes that we are making to this data copy will not affect our original data, and we will have our original data with each and everything that we had originally. Then here we create a function called def introduce missing values. We take in our data frame, we take in the numeric columns, and we take in the categorical columns. Then for I in num columns, so we take for each column or for each item that is in this list of numeric columns. So we select that column and we select some random values here and introduce 1% of missing values. Okay, so that this is what is done here. So for example, if we take this code np.random, then we say, for example, data, we select the education column. You can see what it does. So it picks 1% of the data. Okay, so that's what it does. Then this is done. So same happens for the categorical columns, and we return our data copy. And if we check if our data has missing values, you can see here we have missing values. So any questions concerning this? So this should not stress you because this is unnecessary. So I'm just introducing some missing values into our data so that we can demonstrate the most important parts, which is how to fill in the missing values that we have in our data. So copy this code from the chat box and then we can proceed on from there. So 5 minutes should be enough. So by 8:35, we will go on with the coding. And then you can ask questions if you have any. Okay, so I think we can proceed. So we will start with the data encoding part. So for data encoding, the model that I suggest we mostly use should be the ordinal encoder. And to ordinal encode, so we follow the same processes that we've been discussing. So from sklearn.preprocessing, import ordinal encoder. Then what we do is we instantiate the encoder. So we will have our encoder being equal to ordinal encoder. Then we fit and transform our data. So this is we fit and transform our data, which is the categorical columns alone. Okay. So we will have data missing, then we select all categorical columns. So these are in a list. Then we will have encoder.fit transform, then data missing, then categorical columns. So one thing you need to note is, my guess is we are going to get an error here because already we have missing values in our data. So we need to push this part for removal of missing values up if we want to encode our data. So let's run this and confirm if that's true. So we still have NaNs. Yeah. And since we still have NaNs and our data has been encoded, so how are we going to solve that? So let's proceed on with that here. So we are going to impute missing values, and we are going to use sklearn to impute the missing values. But before we proceed, kindly copy this part and include it in your code as well. So you can see for encoding, it's quite easy. So we will have from sklearn.preprocessing import ordinal encoder. Then we will have our encoder being equal to ordinal encoder. So this is as instantiating the encoder. Then we select our data missing categorical columns. So if we run this up here, so maybe type in .head. Let's pick the original data. You can see that it only returns the categorical columns or the columns that are in string form. So that's what we are selecting here. And we feed the data and transform them. So we have encoder.feed transform, then we have data underscore missing, then we select the categorical column. So those are the columns that we are transforming. So this is how we encode categorical columns. So 2 minutes, you work on that, and then we go to the next concept. Okay, so we can proceed. So how do we impute missing values in sklearn. So we will have from sklearn.impute, we can use knn imputer, but here I will use simple imputer. So it makes works simple. So we will have from sklearn.impute import simple imputer. Then we have to instantiate imputer for categorical features. And we also have to instantiate imputer for numerical features. So here we will have imputer underscore cat. So for the simple imputer for categorical features, we are going to impute with the most frequent, because here we can't take the mean of education, because we already know that for education we have bachelor's, master's, and all that. So we are going to impute that with the most frequent appearing education. So if we take in our data dot missing and check the number of missing values, you can see this is what we have at the moment. But then we can run it again down here after we've done the imputation. Then for numeric columns, we are going to impute them using the mean. So for example, here I'll say strategy should be equal to mean. Then I'm going to fit and transform categorical columns. So that's how we do it. So same code that we were using up here, but ensuring that instead of encoder, which is our instantiated encoder variable here, I use the imputer categorical model that I've instantiated here. Then I do the same for numeric columns. So we have data underscore missing num columns imputer underscore num. Then I fit transform the numerical columns. So let me share this code with you and then we can proceed. So I've run that and then I can check for missing values. So we have no missing values in our data. I can save that. So 2 minutes, you do the same on your side and then we can proceed. Okay, so we can proceed. So here you can see we have no missing values. Then the next part is data normalization. So if we type in data underscore missing, then we select the num columns. Okay, so if we select the numeric columns and type in dot describe. Okay, so let me change this to code. So this is what we get. So for example, you can see joining year is 4653. So joining year should be, okay, so joining year should be, so here on the imputation, we should not have used the mean because we have the joining year. So let's use the median value because this affects this part. But I still see it's okay. So mean works. So we have the mean 2015, mean value 2012, and all that. So it means that when we are scaling, we will have to exclude the joining year column in the scaling part. So let's focus maybe on the age column. So if we pick the age column, you can see the mean is 29, the minimum value is 22, and the maximum value is 41. So what happens when we scale our data? So we are going to import our scaler, and here I'm going to use the standard scaler. So you can also use min max scaler. And then we are going to instantiate our scaler. So our scaler should be equal to standard scaler. Then we fit and transform the data. So data missing, num columns, we fit and transform them. And then we can run that. So what we can do is we can check the data.describe again and see what we have. So if we do that, you can see the minimum value for age has changed to be negative 1.61. The mean to negative 7, the maximum value to be at 2.5. So here you can see the difference between 22 and 41 was 19. But here, the difference that we have between 1.6 and 2.5 is quite small. So basically, that's what scaling does, is it reduces the distance you have between your minimum and maximum value. Okay. So hope this is clear on how scaling works. So it's not a must you scale your data, but it's recommended in cases whereby you are fitting models using large scale data sets. So you can copy these and paste it on your side also. And then we can finish off by creating a pipeline that does all these for us. So instead of us doing all these in different cells, so we can create a pipeline that can at least do all these pre-processing for us. So 2 minutes you copy that and then we can proceed.
Joseph,
Yes.
scalar.
Yeah.
I didn't quite understand what the purpose is.
So the purpose of scaling, so if we go back to our presentation, you can see here features on a large scale can disproportionately influence the model. So like they can influence the model performance. So for example, if we check the presentation for k-means, when we are dealing with these, okay, let's let it load. So when we are dealing with the scatter plot, so we might have values that are really far from some observations that are here. So what scaling does is it reduces these values that are large. So for example, age 41 here, it has been reduced to be equal to 2.5. So 41 here was the maximum values and it has been reduced to be equal to 2.5. Meaning that when we will be doing the plot, so it will be easy for us to like work with these small values that are in a scale that the model can easily recognize. Okay. So scaling is when you are scaling your data, you're just reducing its size so that your model can easily interpret what you have there, we can also search why scale data. So it can help to balance the impact of all variables on the distance calculation and can help improve the performance of the algorithm. So what it does mainly is, first of all, it reduces the time you will have to fit your model, because getting the difference between the minimum value -1.6 and -2.5 will take less time rather than taking the difference between 22 and 41. So that's the advantage of you scaling your data. Has that answered your question?
Yes, yes. But it doesn't change the data. It's the same
No,
outcome, right?
the same, the outcome is same. No changes are done to your data.
So it's some kind of back end.
Yeah, it's some kind of backend so that's why we have it in the pre-processing part. So
Okay.
you are, so if you are creating a product that a user will want to use, so he won't be able to know that you are scaling the data. Yeah,
Okay. Okay. Noted.
yeah,
Makes sense. You can also reverse.
yes,
You can be able to reverse the same part to. Okay. I'm just curious.
yeah, you can
There were
reverse.
things- Okay.
Yeah, so let's do that here. So here you can see scalar.inverse transform. That's what you do to reverse. So you've got your original values. Have you seen how it works? So
Yes. Yes.
you use inverse transform to reverse, then you use fit transform to scale the data. Yep. So I'll leave this here for your reference because I'll share this notebook with you. Yeah. So hope you're done with this part. Let's finalize here. So what I'm going to do is I'm going to create the pipeline to pre-process the data. So here we are going to have from sklearn dot. Okay, so I guess this library changed. So sklearn pipeline. Yeah, so this is the code. So from sklearn dot pipeline import pipeline. So what do you know of a pipeline? So it's a, what is a pipeline? So if we check for images, you can see this is the major route. Maybe, for example, if you want to share water with people in your region, so you have to create a pipeline that will transport this water to each and every household you have. So the same works for sklearn, sklearn pipelines. So the pipelines help you do each and every task you want to do within a single code cell. So here we are going to create our pipeline. So we can say pipe should be equal to pipeline. Then we specify the steps that we need to follow. Okay. So the first step was to impute. So the first step was to encode our data. So that's the first step that we should have here. So what I'll do is I'll create my steps. So here the first step 1 is to, okay, so step 1 should be to encode. Step 2, impute. Step 3, scale your data. So we are going to have pipe being equal to pipeline. Then we specify the steps that we are following here. Okay. So these are the steps that we are going to follow. So instead of us having to like pre-process our data using all these steps, we just use this single line of code and we can check our data pre-processed and see how it appears. So before we do that, let me rerun these code cells that we have up here and get our dirty data, so that if I check my data missing down here, you can see this is the original data. So I want to see the output of data pre-processed. Then we can run that and see. So it outputs an array, and we can convert this array to be a data frame. So let's rerun this step here where we have our data copy, because that's the only cell we need to rerun. And then I can rerun this last cell here for our data pipeline. So if we check the head of this data, that's what we have. So we have our data that has been encoded and data that has been scaled. So this is how a pipeline works. So first of all, you import the pipeline, you specify, you instantiate your model, which is your pipeline. Then you specify the steps. So these steps are in sequence. So here we have a bracket, a square bracket. Let me share this code with you. Sorry, I forgot to do that. So what we do first is we specify the steps. So here you give the step its name and you instantiate the step model in here. So this means you will have to import this model in here. So for example, if it's standard scalar, you will have to import here. You will have to import the model here after importing the pipeline. Then we instantiate our simple imputer and our standard scalar. So you can see this code cell here summarizes what we've done since the start of the class. Okay. So that brings us to the end of today's session. So you guys have tomorrow to practice this, and then we can maybe meet again on Wednesday to discuss some other topics. So that will be these topics here, dimensionality reduction. So that's what we will mainly discuss on Wednesday. And maybe we can use these data set as well to do that. And in the meantime, you can work on this as you familiarize yourself with what we've done today. Yeah, so that's it for me for today. Any questions?